Hey everyone, welcome to the Unit 2 Fall Semester Review. In this first section, I'm going to be going over writing things in interval notation and inequality notation and what the number line graph will look like. So the example I want to go over is just this one with the -8 and the 12. So you see that the -8 is going to the left and it has an open circle. So what's happening is it's moving towards negative infinity, which negative infinity is always in a parentheses. And open circles also indicate parentheses. So we're going to do a union. So I'm going to draw a U here. And then I'm going to talk about the 12 next. So, oops, I didn't lock this down. Looking at the 12, is it an open circle or closed circle? It's a closed circle, and it's going to the right. So it's going towards positive infinity. Closed circles indicate that it can touch it, so that is used with a bracket. And then positive infinities in a parentheses, because infinity is always in a parentheses. All right? So your inequality will look like this. You can go less than -8, right? Y is less than -8. Or y can go greater than or equal to, because you can touch 12. So that's all there is to say about that. I'm going to leave the rest of these examples for you to do. I'm just going to get down to the parent function stuff. So if you're one of my students, you're looking at your paper, all these sketches are blank. So I went ahead and I just put a sketch of that to save time. So these aren't even sketches, these are screenshots. So because I know how terribly I draw. So the first thing is a square root function. Square root function starts at 0 and then goes to the right, saying you can take the square root of 0 and any other positive number, but you can't take the square root of negative numbers. So the domain goes from 0 to infinity, right? It's going from 0 to the right, touching 0 though. Or you can say x is greater than or equal to 0. The range, well, what's the lowest y value? 0, and then it's going in the upward direction. So the range is the same answer, 0 to infinity, or y now is greater than or equal to 0. So I do want to talk about transformations. If you need to use a graphing calculator to figure out transformations, see my video on that, but I'm just going to go over the definitions of this. So you have a 7 on the outside. That's a vertical stretch. So I'll put vertical stretch. I'll write it as neatly as I can. And I'll point to it. I'll point to everything I'm doing. And then the -4 is on the inside, right? So inside goes left or right, and minus goes right. So minus goes right 4. Outside goes up or down. Plus goes up, minus goes down. So +5, up 5. That's all there is to say about this first one. So quadratic is the next function. It looks like that. That's a parabola. All right, so what's the domain? Domain for any quadratic function is all real numbers. It can move left and right. So you can say it with the r, or you can say it with negative infinity to positive infinity. All right, and then what else can I say? The range. The range goes from 0 up. So it's touching 0, right? So y is greater than or equal to 0, or 0 to infinity. Make sure you put the 0 in the bracket. So, yeah. All right, so now let's look at a transformed equation, but I'm giving you the transformations first. Reflect across the y-axis. That means you're going to have parentheses. That means you're going to have a negative on the inside. All right, so you have -x somewhere. It says write 3 units. So remember, minus goes right, plus goes left. And then you can close that and then put the power of 2. Down 2 units. So down 2 is -2 on the outside. And then vertical stretch of 5. That just means you're going to put a 5 on the outside. And then, you can just put a f of x equals or g of x, whatever you want to put. I guess you should all say g. It's a small detail, but it's like when you transform the equation, the letter is supposed to change. Oh well. It's too late now. All the other ones say f of x. Okay, so that one's done. Cubic. Looking at it from left to right, all real numbers. It's on the left side, it's on the right side. That's how you know. Is it on the left side and the right side? And then the range, is it going up and is it going down? Yes. So they're both all real numbers. So, just say it with the r's or with the infinity sign. I'm just going over both ways because when we write tests, we like to just put both types of forms on there, the inequality and interval notation, just to test to see if you know both of them. All right, so we have a negative on the outside. All right, so that means we're going to reflect. Negatives just make it reflect. It's either x or y. X is on the outside, y is on the inside. So I'm going to put reflect x-axis. And plus 2, that's on the inside, right? It's in parentheses, so that's going to go left 2. Remember, plussing goes opposite of what you would expect. I always tell people, oh, inside stuff's left and right. So they think plus goes right, minus goes left. But nope, it's opposite of what you would expect. So plus goes left. And that's it. Yeah, that's it for this first little bank. Now let's do this second bank. This is a logarithmic function, log x. So you can see that it just kind of curves and waterfalls down like that. So that means it's about to touch 0, but it never does touch 0. So we say that it's going to the right, isn't it? So that means x is going to be greater than 0. But it can't be or equals to. It doesn't touch it. So it goes 0 in parentheses, infinity in parentheses. All right? The range is the same thing? No. The range is on the bottom and on the top. So the range is all real numbers. All right? So, yeah. Got to look at it two-dimensionally, right? Left and right, that's one-dimensional. Left and right, and then up and down. So, yeah. Sorry, I guess I'm talking to myself here. Anyway, here's this. We got a 3 on the outside. What's the outside multiplication going to do? It's either vertical stretch or vertical compress. The bigger the number, if the number's bigger than 1, it'll stretch. If it's smaller than 1, it'll compress. It doesn't matter if it's negative, though. So this is vertical stretch. And then I'm going to fix this R. Not much better. So negative on the inside, that's a y-axis reflection. All right? So y-axis reflect. The plus 2 is on the inside, so that's going to make it, I should do different colors. Plus goes left, minus goes right, just like we did on the last one. So plus goes left 2. And then there's a minus 5 on the outside. That's making it go down 5. All right. So that's it for the logarithmic example. This one's absolute value, V for value. It makes a V-shaped graph. You can see it's going left and right, so that's a domain of all real numbers. But the range is starting at 0 and then just going up, so no negatives. So the domain, all real numbers. But the range is just greater than or equal to 0, or 0 in a bracket, because you can touch that 0 to infinity. So the logarithmic can't touch the 0, that's why it's in parentheses. But absolute value can't touch the 0, that's why it's in a bracket. Exponential, this is an exponential graph where b is greater than 1. So b to the power of x indicates that you're going to plug in some number for b, and x is in the exponent. That's the difference between an exponential equation and something like a quadratic equation or a cubic equation. X is not the exponent, a number is, okay? So if x is the exponent, it's exponential, and it just kind of goes like this. It starts off, and then boom, it takes off. So this x, the domain, it's going left and it's going right. So that's a domain of all real numbers. So all real numbers, Now let's talk about the range. The range can't go to the negative side, so it's only greater than 0. Can it touch 0? No. You know if it can't touch 0 if it just kind of flatlines like that. So this one's going to be like the one 2 examples ago. It's going to be greater than 0, not greater than or equal to, just greater than. Or it's going to be 0 in a parenthesis to infinity parentheses. So yeah. Now, looking at this transformation, ignore the 5 because I said b is greater than 1. So b is just a number you plug in. So we're just looking at the plus 1 and the minus 2. So the plus 1 is on the exponent. That counts as being on the inside. So that's going to go left 1. The minus 2 is on the outside. It's not part of the exponent. So that's going to go down 2. All right? So that's all there is to say about that exponential one. Okay? So we got cube root next. Cube root makes this kind of S-like looking graph. It looks like the Santikos logo. Shout out to San Antonio movie theaters. So this is a domain of all real numbers. It's on the left side, it's on the right side. It's a range of all real numbers too, because it's on the up and on the down. It's on the positive and negative. So I'm going to put all real numbers for both answers. All right, and that'll take care of the domain and range part. All right, and let's look at the transformations. It says reflect across the x-axis. So that means we're going to have a negative out in front, not on the inside with the radical outside here. So I am going to put a negative, and then I'll put a little cube root. All right, and then it says it goes right 4 units. So right 4 would mean minus 4 on the inside. Down 3 units means minus 3 on the outside. And a vertical stretch of 3, that means you're going to put a big 3 on the outside, not like the little 3 that's inside here. This indicates a cube root. Just didn't want it to be confused with that. And then just throw an f of x or g of x equals something like that. But that would be the equation for this one. And then my last one to go over here is your rational graph. That's 1 over x. X is on the bottom of a fraction. So this one's special because you can never touch 0 on x or y. You can see that it's kind of flatlining, going up and down. So it's going on the positive and the negative side and left and right. So positive and negative side for both x and y. The only thing is it just can't equal 0. So sometimes you see it represented just as x can equal 0. And then that's just supposed to indicate that it can equal everything else. Otherwise, you see a union, like negative infinity to 0, union 0 to positive infinity. Or you see x is greater than 0, less than 0, or x is greater than 0. You know, the union just means the word or. All right. I don't think I mentioned that in the first example that I did. The y one's exactly the same except with the letter y. Y can't equal 0. You might see that. Or you see in parentheses negative infinity to 0 union, meaning or, 0 to positive infinity. Or you see that y is less than 0 or y is greater than 0. And so that takes care of the domain and range. Now here we have a plus 2. That's part of the fraction, right? So that counts as being on the inside. So that means it's going to go left 2. All right, and then this minus 5 is on the outside, so that's going to go down 5. You know it's on the outside because it's not part of the fraction. And that's going to wrap this up. So, oh no, it's not going to wrap this up. I skipped the absolute value transformation. We have a vertical compression of 1/2. That means we're going to have a 1/2 out in front. And then it's going to go left 4 units. So that means I'm going to plus 4. Sorry, my phone's vibrating. Plus 4 in the inside. and then up 7, plus 7 on the outside, and then reflect across the x-axis, negative out in front. So throw an f of x equals, and yeah, now we're done, okay? So the thing to focus on, really study, is those transformations, and then know how to recognize your domain and range, okay? So is it on the left and is it on the right? Chances are, then that means it's all real numbers, for domain. Is it up and is it down? Then the range is all real numbers. And then, you find your restrictions by seeing where it can't go, like this can't go to the negatives, all right, because it's not going below or going left. So yeah, just those are the things you'll want to study, and thanks for watching. Bye.